Welcome to qnawire.
In this problem, we're given a secret code that we have cracked, and we know that each of these numbers represents an atomic symbol, but in the way that it is the sum of the atomic number plus the highest principal quantum number. Now, the principal quantum numbers are related to electron configurations. They're essentially just the periods in most cases. In actually all cases, we have to note that it's for the highest occupied orbital, so D is slightly lower and F slightly lower than that. Important to note. But essentially, it's going to be the atomic number plus the period. So we might start decoding 10. Okay, well, we can go to 10. And obviously it's not 10, though, because we'd have to add 2. We'd be at 12. So we'll subtract 2, perhaps. And we'll be at 8. So that is an O. 12, we might consider the same idea, except we just noted that if we are at neon, then 10 plus the period 2 is going to be 12. So O and E. At 58, we can do the same thing. We can come to 58 exactly. And we might notice that if we then subtract 5 or 6, we'll be at 52. So we're a little too far. So we might consider something different. We might say, well, 53 iodine plus 5, the period that iodine occupies, or its highest principal quantum number, is 58. So I. 11, well, we might go back to period 2, or 9 plus 2 is 11, so fluorine, F. 7, we might consider going directly to 7 and then going back 2, which brings us to boron, so B. At 44, we might go straight to 44. Okay, we're at ruthenium, but we'd have to add 5, which would bring us to 49, so instead we'll subtract 5. So we'll go to the left 5, and we'll come to Y, or yttrium, so there we are. 63, we might go straight to 63, and then again, subtract the period would be the easiest way to decode this. So 63 minus 6 is 57, which is lanthanum, La. And at 66, we might do the same thing. Go to 66, subtract 6, and we end up at neodymium, so Nd, and we have 1 if by land. Now, for the next one, we might rinse and repeat the same thing. So in this case, I'm going to go a little bit faster. So 9, we can go straight to 9, subtract 2 at N. At 99, we can go to 99 and subtract 7. At 92, we have U. For 30, we can go straight to 30 and subtract 4. We'll have 26, iron. At 95, we can look around. We go straight to 95. We'll subtract 7. So 1, 2, 3, 4, 5, 6, 7. Radium. At 19, we can't quite get there. So we'll go to the third period and we'll say it's sulfur plus 3. So 16. Whoops. Sulfur. And we have 47. We'll go straight to 47, subtract the period of 5, which will bring us to molybdenum. So MO. And finally, 79. We can go straight there and subtract the period of 6, bringing us to 73, Ta. And it does say in the problem that they can be written forward or backwards. So we might say, well, nu pharasmata is not a word, but we can say atoms are fun.